Hey students, so today we are going to start the second chapter, Force and Laws of Motion. Introduction. In the previous chapter, we have discussed how motion is described in terms of velocity and acceleration. Now, what causes a body at rest to move? What causes a moving body to come to rest? What causes a body to accelerate or decelerate? Our answer is that in each case, a force is required. So, let us try to understand what is force. So, in simple words, a push or pull on a body is called force. As you can see in the diagrams, you are pushing the block of wood away from you or you are pulling the block of wood towards you. That requires a force. Now, what are the effects of force when applied on particular objects? First, a body at rest can be moved by a force. Second, a body in motion can be stopped by a force. A body in motion can be changed in its direction of motion by a force. For example, the game of football. The ball changes direction every now and then, whenever being hit by the player. So, that is an example of force. Force applied can change the direction of motion. A body, for example, here a spring, can be changed or stretched in its shape or size by a force. So when force is applied, spring can be stretched, and again when the force is applied, the spring can be compressed in shape and size, and it happens because of the force applied in the certain directions. Now, to conclude, what is force? Force is an external effort which may move a body at rest or stop a moving body or change the speed of a moving body or change the direction of a moving body or change the shape and size of a body. And these are the effects of forces. Force can move a body at rest, force can stop a moving body, force can change the speed of a moving body, force can change the direction of a moving body, and force can change the shape and size of a body. All the effects you can see in the pictures given below 1, 2, 3, 4, and 5. These pictures shows you the effects of force. That force can help in moving a body. It can stop a moving body. It can change the speed of a moving body. It can change the direction of a moving body, and it can change the shape and size of a body. Now, how do you represent force? Force is always represented by an arrow because it is a vector quantity. The length of the line represents the magnitude of force, and arrow represents the direction of force. For example, a force of 5 N means Newton can be described graphically by drawing a line of 5 centimeter length and placing an arrowhead on one of its ends, which is indicating the direction. So two boxes show 1 centimeter here. So 10 boxes will represent 5 centimeter. Now PQ is equivalent to 10 boxes. So 10 boxes is equals to 5 centimeter. This becomes the magnitude of force. So the magnitude of force is 5 centimeter. Now the arrow here indicates the direction. So this is towards the north direction. So we can write PQ equals to 5 centimeter or 5 Newton. This N does not stands for north direction. It is actually the SI unit of force, which is Newton, and it is always written in capital letter, that is 5N. What is indicating the direction of force is this arrow head on top of PQ. It is showing you that PQ is actually a vector quantity which has a value of 5 Newton. So this is how you represent force. Now let us see types of forces. First, we should know what is resultant force. Any object can be made to move by the application of force. Many forces can act simultaneously on a body. For example, several people can jointly move a boulder, but a strong person can move the same boulder all by himself. That is, the force applied by strong man produces the same effect as that produced by the net force applied by all the people. The force applied by the strong man is the resultant force. Pictorial wise, you can see this representation here. The resultant force is that single force which, when acting on a body, produces the same effect as that produced by a number of forces. So here in the picture you can see four people are moving a boulder, and the forces applied by them is F1, F2, F3 and F4. Now in the next picture, a single person is moving the same boulder. So the total force or the net force or the resultant force applied by him is F is equals to sum of the forces applied by the four people, that is F1 plus F2 plus F3 plus F4. So the force applied by a single man is equivalent to the forces applied by four men, and this is how this becomes the resultant force. Under types of forces, we have first balanced forces. If the resultant of all the forces acting on a body is zero, the forces are called balanced forces. So in this diagram, you can see a block of wood is being exerted by many forces, and all the forces are balanced here. How? The force F applied by the left hand is being balanced by the force F applied by the right hand. Both are equal and in opposite direction, hence they are balanced. The weight of the block or the force of gravity on the block is being balanced by the reaction exerted by the table on the block. So this is an example of balanced forces. All the forces are being balanced here. So there is no change in the position of the wooden block. Things to note down. First, when a body at rest is acted upon by balanced forces, the body is not displaced. As I said earlier, that is, the body remains stationary, there is no change in its position. Second, when balanced forces act on a body moving with constant velocity or uniform motion, they do not produce any acceleration on the body. That is, the body continues to move with the same speed and direction. For example, and a very good example given here, that when raindrops fall from clouds at a greater height, the drops at first gain velocity due to gravity of the earth. After falling through some height, a stage called equilibrium occurs. So some points to note down here. First, when a body at rest is acted upon by balanced forces, the body is not displaced. As I said earlier, there will be no change in the position of body and the body remains stationary. Second, when balanced forces act on a body moving with constant velocity or uniform motion, they do not produce any acceleration on the body. That is, the body continues to move with the same speed and direction. So example given here is, and it is a very good example, that when raindrops fall from clouds at a greater height, the drops at first gain velocity due to gravity of the earth. After falling through some height, a stage called equilibrium occurs when downward weight of the drops is balanced by the upward forces such as upthrust and viscous force. The net force acting on the drops will be zero because both the forces are in opposite direction and hence no more acceleration is produced on the drops. Therefore, the raindrops move with constant velocity, which was last gained by the drops just before reaching equilibrium condition. Now, to understand in a better way, you can do some mathematical calculation here and just see the practicality of this example. Can you imagine the speed of the raindrops while reaching the surface of the earth? If they continue to move only under the action of gravity, what will happen then? Suppose the clouds are at the height of 3 kilometers or 3000 meters. Now, acceleration due to gravity, that is, the acceleration under gravity, is always equals to 9.8 meter per second square. Since the initial velocity for the raindrops going to be 0 meter per second, Now we are going to apply the equation of motion here, that is v square equals to u square plus 2as. Acceleration here changes to acceleration due to gravity, and distance here changes to height. So this becomes 2gh. Placing the values after doing calculation, what we will see that the final velocity is 617 kilometers per hour. So our raindrop with such a high velocity is faster than a bullet and can pierce through a human skull. So this is a very good way of understanding. Third point, though the balance forces cannot produce motion in a stationary body or stop a moving body, they can, however, change the shape of the body. For example, when a ball is pressed between the hands, the forces are balanced, but the ball is changed in its shape and size. Now let us talk about unbalanced forces. If the resultant of all the forces acting on a body is not zero, means resultant force is not zero, the forces are called unbalanced forces. Unbalanced forces can move a stationary body or they can stop a moving body. When we talk of a force acting on a body, we usually mean an unbalanced force. When the total force on the plane is in one direction, the force is called unbalanced. An unbalanced force changes the motion of the plane. For instance, when thrust is greater than drag, it is the unbalanced force that causes the plane to speed up or accelerate. And in addition, as the velocity of the plane increases, the lift force increases and becomes the unbalanced force that causes the plane to fly. Now, to conclude, balanced and unbalanced forces. First, balanced force. If two forces act on a body in opposite direction, and if both the forces are equal, then the resultant force acting on the body is zero. Such forces are called balanced forces. Balanced forces cannot change the state of rest or motion of a body. So here you can see F1 is equals to F2. Unbalanced forces, if two forces act on a body in opposite direction and if one force is greater than the other, then the resultant force is not equals to zero. Such forces are called unbalanced forces. Unbalanced forces changes the state of rest or the motion of a body. It can either be F1 greater than F2 or F2 is greater than F1, and the movement is always towards the greater side of force. If F1 is greater than F2, so the block of wood will move towards the left hand side, and if F2 is greater than F1, then block of wood will move towards the right hand side. So my kids, what we studied today, based on that, here is your homework. Thank you.